The question is, radium decomposes at the rate proportional to the amount present. If P% of the original amount disappears in L years, how much will remain at the end of 2L years? If you remember the statement what we have written, the rate of change of amount of substance is proportional to amount of the substance present, not the disappearing one. So we have to use, or we have to remember that statement. Accordingly, we have to modify and we have to write the given data. See that here also the initial amount is not mentioned. So we'll take in the same way that n is equal to n0 at time t is equal to 0. Let n is equal to n0 at time t equal to 0. What he says is P% of the original amount disappears. P% of the original amount disappears. Then how much remains? P% of n0 disappears in L years. If I say that 95% disappears in 1 year, then 5% is as it is. So in the same way, I have to take out how much is present there, not the one which disappears. So n is equal to n minus or n0 minus P% of n0 at time t is equal to L years. The total amount was n0. So from that, take out the amount which disappeared. The amount disappeared was P% of n0. So original amount is n0. I'm taking out the disappeared amount. So I got n is equal to n0 minus P by 100 of n0. So I can write it as n is equal to n0 1 minus P by 100. If I take out n0, that becomes 1 minus P by 100 at time t equal to L years. So I'll mark this as A and I'll mark this as B. Then next what is said is how much will remain at the end of 2L years. So n is equal to question mark at t is equal to 2L years. This is, I take it as equation C. If you observe from this problem, whatever the initial amount was there, it is decreasing as the time is increasing. So therefore, this is clearly a problem of decay. So from the law of natural decay, dN by dt is equal to minus k into t. Why I am writing minus sign? I told you earlier that as the time increases, the amount decreases. So for showing that amount decreases, I should put there minus sign. So dN by dt is equal to minus k into t. On integrating this, I'll get that as n is equal to c into e power minus kt. So I'll treat this as equation 1. N is equal to c into, yes, we got n is equal to c into e power minus kt as the equation 1. Now we'll start using the given data. Using equation A in 1, we get n is n0 at time t equal to 0. So n0 is equal to c into e power minus k and time is 0. And we know that e power 0 is 1. So therefore, we get c is equal to n0. Since e power 0 is 1. I got the value of c, then I'll use this in the recent equation what we got. Using c value in equation 1. So we get that as n is equal to n0 into e power minus kt. N is equal to n0 into e power minus kt. So I'll mark this as equation 2. Now I'm going to use the next condition in this, using equation B in equation 2. Using equation B in equation 2. In equation B, it is mentioned that n is equal to n0 into 1 minus p by 100 at time t is equal to L years. So I'll replace that n and t values here. So I'll get that as n0 into 1 minus p by 100 is equal to n0 into e power minus k into L. So here n0 get cancelled. So I'll get that as e power minus kl is equal to 1 minus p by 100. I got the value of e power minus kl. Here I am not calculating the value of k. Why? Because it is mentioned there at the end of 2l years. So I may get back again the same type of exponential function. Now using condition C in equation 2, condition C in equation 2, that is n is equal to, what it is mentioned there is at the end of 2l years how much amount will remain. So n is equal to n naught into e power minus k into 2l. Here it is given time, we have to calculate the amount of the substance present at that time. So n is equal to n naught into e power minus k into 2l. Then I can write this as n by n naught is equal to e power minus kl whole square. As we know that e power 2x, we can write it as e power x whole square. So I can write e power minus kl whole square as n by n naught. Then this becomes from the above, from the previous one, from previous equation, e power minus kl is equal to 1 minus p by 100. I'll use that value of e power minus kl in the above equation. I'll get that as n is equal to 1 minus p by 100 whole square by n naught. I'm using e power minus kl value in the previous equation. So I'll get n by n naught is equal to 1 minus p by 100 whole square. Or I can write it as n is equal to n naught into 1 minus p by 100 whole square. So this much amount will remain at the end of 2l years. Yes, he mentioned there that the p% of the original amount disappears. Then how much will remain at the end of 2l years? So this much remains at the end of 2l years. Now we'll see one more problem on decay. Problem 2. If 30% of radioactive substance disappears in 10 days, how long will it take for 90% of it to disappear? Again, the problem is in the same way. What is asked is, if 30% of the radioactive substance disappears in 10 days, how long will it take for 90% of it to disappear? Again, see that the original amount is not mentioned, so we'll assume in the same way. Let n is equal to n naught at time t is equal to 0. I'll mark this as equation A. Then what is it is 30% disappears. Then how much will remain? 70% will remain as it is. So I said just now that we have to count the amount what is present, not the one which disappears. So n is equal to 70% of n naught, or we write it as 0.7 n naught at time t is equal to 10 days. So I'll write this as equation B. Then what the question is asked is, how much time will it take for 90% of it to disappear? 90% of it to disappear is the same as 10% to be as it is. So I'll write it as n is equal to 10% of n naught, so which is equal to 0.1 n naught at time t equal to question mark. Is that clear what we have written? It is given that that is 30% of the radioactive substance disappears. Initial amount is not given, so we are writing that as n is equal to n naught at time t equal to 0. Then he said 30% of the radioactive substance disappears. Then how much remains is 70%. So I am writing there n is equal to 70% of the original amount, that is 0.7 n naught in time t equal to 10 days. Then the question asked is, in how many days 90% of it will disappear? It is similar to n is equal to 0.1 n naught, 10% of the original amount to be there, then what that time is. So this is clearly a problem of decay, so we'll use law of natural decay. from law of natural decay, dN by dt is equal to minus k into n. Then by using the variable separable method and integrating it, we get that as n is equal to c into e power minus kt. So I'll write this as equation 1. Okay, we'll take this as equation c and we'll take this as the equation 1. Now again applying the same procedure, using equation a in this, we'll get the value of c. Using b in this, we'll get the value of k. Finally, we'll get the solution. Using equation a in 1, we get n naught is equal to c into e power minus k into 0. I substituted equation a where it was mentioned n equal to n naught and t equal to 0. So I'll get here c is equal to n naught as e power 0 is 1. So I got the value of c. I'll substitute this value of c in the previous equation. So I'll get that as n is equal to n naught into e power minus kt. So I'm getting the equation as n is equal to n naught into e power minus kt. I'll write this as equation 2. Now I'll use the equation b in this recent equation what I got. Using equation b in equation 2. Then that gives 0.7 n naught is equal to n naught into e power minus k into 10. 0.7 n naught is equal to n naught into e power minus 10k. So n naught if I cancel, then I'll get that as 0.7 log to the base e is equal to minus 10k. Then we'll see ln 0.7 then divided by minus 10. So that gives k value as 0.0357. K value is giving us 0.0357. Yes, I got the value of k. Using this value of k in equation 2. Using this value of k in equation 2. We get that as n is equal to n naught into e power minus 0.0357t. Yes, substituting this value of k, we get that as n is equal to n naught e power minus 0.0357t. Then I'll mark this as equation 3. Using equation c in equation 3. In equation c we wrote n is equal to 0.1 n naught and we have to get the value of t from that. So 0.1 n naught is equal to n naught e power minus 0.0357 t. So this n naught and this n naught will get cancelled, and again I'll send this e the other side. That becomes log to the base e 0.1 is equal to minus 0.0357 t. So we'll get ln 0.1 divided by minus 0.0357 divided by minus 0.0357. So we'll get it as ln 0.1 divided by minus 0.0357. So we'll get it as t is equal to 64.4982. 64.4982, or I can write approximately 64 minutes or 64 days, because it is mentioned in days. So if 90% disappear, what he has given is 30% disappears in 10 days. For 90% of it to disappear, it will take roughly 64 days. The other problem based on law of natural decay. So we'll start the next problem. A radioactive substance disintegrates at a rate proportional to its mass when mass is 10 milligrams, the rate of disintegration is 0.051 milligrams per day. How long will it take for the mass to be reduced from 10 milligrams to 5 milligrams or to its half? You are given the question as a radioactive substance disintegrates at a rate proportional to its mass. When mass is 10 milligrams, the rate of disintegration is 0.051 milligrams per day. How long will it take for the mass to be reduced from 10 milligrams to 5 milligrams or to its half? Yes, clearly here this is the problem of decay. So we'll write the given data first and what is mentioned in this. A radioactive substance disintegrates at the rate proportional to its mass, and it is given that when mass is 10 milligrams, the rate of disintegration is 0.051. From law of natural decay, dN by dt is equal to minus k into n, and it is given here that the rate of disintegration is 0.051 milligrams per day. Disintegration, so it is going to decrease, so therefore we represent that with the minus sign. So minus 0.051 is equal to minus k. At what mass? It is mentioned here when mass is 10 milligrams. So we'll write in the place of n as 10. So we get that as 10k is equal to 0.051, or we'll get k is equal to 0.0051. So we get the value of k as 0.0051. From the law of natural decay, dN by dt is equal to minus kn. On integrating this, we got that as n is equal to c into e power minus kt. N is equal to c into e power minus kt. Already we got the value of k. I'll substitute that in this. So I'll get n is equal to c into e power minus 0.0051 t. I'll mark this as equation 1. Now what the question was asked is, from 10 milligrams to 5 milligrams, how much time will be taken? So I have to calculate the value of t from this. So given n is equal to 10 initially, it is given n equal to 10 milligrams initially. So I'll write here n is equal to 10 at time t is equal to 0, and I'll mark this as equation A. Then what is said is how much time will it take for reducing it to half. So n is equal to 5 milligrams at time t is equal to question mark. I'll write this as B. Now we'll start using the equation A in 1. Using equation A in 1, we'll get that as 10 is equal to c into e power minus 0.0051 into 0. And we know that e power 0 is 1. So therefore we'll get that as c is equal to 10. We got the value of c as 10. So using c value in 1, we get n is equal to 10 into e power minus 0.0051 t. So I'll write this as equation 2. Now we have the last equation. From that we can get the value of time taken. So using equation B in 2, we get 5 is equal to 10 e power minus 0.0051 into t. Then we'll get that as 5 by 10 log to the base e. If I shift this e this side, log 5 by 10 is equal to e power minus 0.0051 t. Then we'll find the value of ln 5 by 10. So 0.5 ln 0.5. So that becomes minus 0.6931 is equal to minus 0.0051 t. So from this I'll get the value of t. So divided by minus 0.0051. So I'll get the answer as t is approximately 136. Yes. For reducing the mass to its half, it takes approximately 136 days.